Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on rectification from March 2022, Paper 4, Variant 2. In this lesson, we will discuss how to complete full wave rectification circuit, and also we will discuss how to write the equation for sine graph. At the end of the video, we will also discuss how to calculate mean power dissipated in a resistor. For question number 7, part A, it is given to us alternating current is converted into direct current using a full wave rectification circuit. Part of the diagram of the circuit is shown in figure 7.1. For part A, we need to complete the circuit in figure 7.1 by adding components in the gaps, means in these gaps. For the second part on figure 7.1, we have to use plus sign to mark the positive output terminal of the rectifier. This is kind of typical question, and you will see this question in many past papers. So now I will explain you one very important method to handle this type of problems. I will explain this question with the help of answers. So let me show you the answer first, and then I will explain you how you can write down the answer. So this is what question is asking you to complete the diagram. First of all, for part 1, you have to draw these two diodes. This is diode 1, I can say you have to draw here, and this is the second one you have to draw here. And the question was asking you to use the positive sign. So in this case, this is the positive sign. And this one we can say is negative. Positive sign simply tells us means current always will flow. Imagine that this one is a resistor. So simply we can imagine that this is a resistor. So this is DC output. You can imagine there is one resistor. So in this resistor, current will always enter from this side. So that's the reason we mark this side as positive side. Current will enter always from this side. So that's the reason with the help of this circuit, we have converted AC into DC, because in this component current flow only in one direction. So this is how we have converted AC into DC. Now let me explain to you how to complete this diagram. So we will look at these points. So first of all, we will look at point A, and let's say this is point B, and let's say this is point C, and this point is point D. Now, if you look at point A, it is connected with one terminal of the resistor, and B is connected with other terminal. But if you look at these points here, if you look at diodes now, these diodes, they diverge. You see, they are diverging. So these diodes, they diverge. So simply we can say they are diverging at this point, diverge. And where these diodes, they diverge, that is always negative. And if you look at this point, these diodes, they converge to this point. So we can say this point where these diodes converge, and that side is always connected with positive. So this is the point you need to understand. Where these diodes diverge means go away, that is negative terminal of this DC output, and the point where they converge, that is connected with positive terminal of DC output, or you can say resistor, and remaining two terminal you can connect with AC input. So this point, other 2 points, points C and D, they are connected with AC input, and this is true for any shape of bridge rectifier circuit. How they draw, it doesn't matter. If it is a full wave rectifier circuit, you can just follow these points. Where diodes diverge, that has to be negative terminal of DC output. Where they converge, that one has to be positive terminal of DC output. And the remaining 2 points, you can just simply connect with AC input. And this is how you can answer. Let me know if you have any questions about full wave rectifier circuit in comments section. For part B, the output voltage V of an AC power supply varies sinusoidally with time as shown in figure 7.2. So as you can see, simply this is a sinusoidal graph, or this is simply a sine graph. In this case, you can see on y-axis we have voltage, and on x-axis we have time. For part 1, question is asking us to determine the equation for V in terms of T. where V is in volts and T is in seconds. So if you look at this graph, this is a sine graph. So we can write down the equation for sine graph. So V as a function of time, this will be equal to V naught, means the maximum value of V times sine of omega t. Sine of omega t. Now we need to plug in values of V naught and omega. First of all, the value of V naught means the V max we can read from here. V max is equal to 3.5. So simply we can write down V naught is equal to 3.5 volts. Now we need to find out value of omega. That omega is equal to 2 pi over t, and t is the time period. Now if you look at this sine graph, this is one complete cycle. So this is one complete cycle. So we can read the time period from here. Time period in this case is equal to 2.5. So we can replace capital T with 2.5. So this is time period 2.5. If we simplify this one, means 2 divided by 2.5, and this is multiplied with pi. So we will get 0.8 pi, and this is value of omega. Now simply we can replace V naught with 3.5 sine of omega t, and omega is equal to 0.8 pi times t, and that's all what we need to write down for this question. And this question has 2 marks. This question has 2 marks, and the first mark you will get if you have got the right value of omega. So this is C mark. And the second mark is A mark. If you have got the right equation, you will get the second mark, and this is A mark. But if you have got the right answer, so still you will get 2 marks, even you haven't written this one, so you will get 2 marks. But if your answer is wrong, you have calculated value of omega right, you will get 1 mark. For the second part, it is given to us that the power supply is connected to 12 ohm resistor, and this is the output of the power supply, and question is asking us to calculate the mean power dissipated in the resistor. So we have to calculate the mean power dissipated, so simply we can say this is P mean. In order to calculate P mean, we have to use RMS value of the V. So we can say V RMS square divided by R. So this is how you can calculate that V RMS. So let me write on here V RMS. This is equal to peak value of V, means V naught, or simply you can say the peak value of V divided by root of 2. Now we can replace V RMS with peak value. So we can say this is the peak value divided by root of 2 and the square of this, and this is divided by R. Now if we simplify this one, we can say this is V peak value of V square divided by 2R. And now we can plug in values of peak value and resistor. So in this case, the peak value is 3.5. We have already discussed. This is peak value 3.5. Peak value is 3.5, and this is divided by 2 times the resistance of resistor. And now we can simplify and we can get the final answer. In this case, the final answer will be 0.51 watts. And this is the final answer. This answer has to be up to 2 SF, because this has 2 SF and this also has 2 SF. Least number of SF. So this is our final answer for this question. This question has 2 marks. If you have written the right formula, you will get 1 mark, and that is C1 mark. And the second mark is answer mark. If you have got the right answer, you will get the second mark.